Okay, so this is 13.4, number 20. And I have two planes, 2x minus 3y plus 5z equals 2, and 4x plus y minus 3z equals 7. Sweet. Planes. Probably those planes look like this. Right? Like, probably. They don't have to look like this. For instance, planes could look like the floor and the ceiling. Right? In that case, why is this picture inaccurate? Yeah, there's no intersection, right? They're just parallel. Most planes, right, if you pick a pair of planes out of a barrel at random, right, they will hit one another someplace, and that intersection will look basically like this or something. It depends a little bit on your perspective, right? But yeah, it's in there. Right? They'll make some kind of a plus signy thing. So for the purpose of this exercise, my two planes will be this board and this board. These are probably a good intuitive example because they're not at a right angle, right? It would be a little weird if I picked the wall and the floor because there's something really special going on there, right? That right angle is super special. Whereas this is just like, I don't know, there's some angle here. We could probably figure out what it is, but I don't want to. Cool? All right, so these are my two planes that I'm thinking of. And then in the problem, they're asking for what? They're asking for a vector parallel to the line of intersection. Okay, so this is the line of intersection here, right? And so they're looking for a vector that's parallel to that somewhere. You guys all with this? So if these are my two planes, right, that line of intersection is over here in the corner. But the vector that I'm getting out of my answer doesn't have to be over there. It just has to be somewhere, right, parallel to that. You guys all cool with this?
Why wouldn't it have to be in the corner, though? If it's the line of intersection, wouldn't it have to be like right where they...
Yeah, so if they said, find a vector contained in the line of intersection, then it would have to be over there. And then I would have to do like a displaced vector where I told you what the base was. But thank God they didn't ask for that because they knew what they were doing. So they're just asking for some vector parallel to that thing. So, thoughts?
Make the functions equal to each other.
Oh yeah, we could like set them equal to each other somehow. How would you do that? What do you think?
Put the numbers to the side and this equals 0.
Oh, definitely don't do that.
No.
No. Why not? So if you shovel the numbers to one side and then have them equal to 0 and set them equal to each other, how many variables are there going to be at both sides?
4.
At both sides.
Yeah, in each side there will be 3 variables and a constant term, right?
Yep.
Will any of the variables cancel?
No. We'll just basically get a third plane.
Yeah, you will get something bizarre, right? So what's the problem there? In that process, you're not eliminating a variable, right? Let's actually eliminate a variable. How could I do that?
Substitute everything for y.
Yeah, I could like pick what y is in this one. You guys see that? So I could take this bottom equation and rethink it as y is 7 minus 4x plus 3z. You guys all playing along with that? And then I can cram this crap into the first one, right? So then I'll have 2x minus 3 times 7 minus 4x plus 3z plus 5z equals 2.
So when we do that, what are we saying exactly? Like, Are we saying that we're going to set y in the first equation equal to?
This is a super good question, right? What in the hell is going on? You guys see that? Yeah, this is really me thinking of, I'm thinking of y as a function of x and z, right? You guys see that? And then I've kind of got another function of x and z, right? I'm thinking about y over here is also a function of x and z, and I'm sort of setting those two things equal to each other. This is a really terrible method for this. You guys want a better one? Like one that uses the thing you learned in this section about cross products?
Yeah.
Yeah, maybe. This would work. Like you could untangle this idea here. It is a lot easier to know something about planes and use it. So first I'm going to tell you something about planes, and then we'll decide whether or not it was fair to assume you knew that. Okay, so here's a plane, right? My claim is that a normal vector to that plane is given by 2, -3, 5. What's a normal vector?
Vector perpendicular to the surface it is.
Yeah, right? So a plane is flat, and a normal vector sticks straight out of it. You guys see that? So in that case, that would be, right, in my wall example, that n vector is this one. You guys buy that there's a unique, up to length anyway, vector like that? Because if I grab this thing, right, if it's truly perpendicular to that plane, and I torque on this, I'm going to bend the plane, right? You guys see that? Or I'm not going to be able to move it. Pick one. Right? So using that, what would the other normal vector, which I'm going to call m, I guess?
4, 1, -3.
Okay.
So you ignore the outside number then when you're doing these normal vectors?
Yep. Just pull the coefficients off. Everything's got to be on the same side, but the constant term doesn't matter.
Oh, that's why we're only having to do it parallel.
Yeah.
Like, we'd have to take that account if we were trying to get the exact spell.
Yeah. We'd have to think a little harder. It's not a lot harder, but it's a little harder. So that's this vector, right? Now, where's the line of intersection live relative to those? Yeah, you guys see that? It's perpendicular to both of those. It's got to be perpendicular to both of those because that line of intersection is in this wall, so it's perpendicular to this normal vector. And that line of intersection is also in this wall, so it's perpendicular to this one. You guys see that? So how do I get a perpendicular vector to a pair of vectors?
Cross products.
Yeah, don't think. Get out the cross product and do it. Right, so I want to calculate m crossed with n. And that's going to be, put your I, your j, and your k. Oh, and I said m crossed with n. Does that make any difference at all?
It changes whether it's positive or negative, but that's it. They end up being both parallel to each other, so it ends up being.
You guys see that? If I do m crossed with n, I'll get one pointed that way. If I did n crossed with m, I would get one pointed up. Does it matter?
They're both parallel, so.
Not really. I don't even know which one's up and which one's down anyway, right? Because I just kind of drew this picture at random. This is not a good picture of the situation. You guys cool with that? Okay. So if I do this calculation, what do y'all get? Should get some i's, right? How many i's you get? So remember, I'm covering up the row and the column, and I'm doing this minus that gets me 1 times 5 minus 3 times -3, which is just -4. So I got -4i, then I got a minus some j's and plus some k's. So the j's are what? 20 minus -6?
Yeah.
Okay, so I got 26, make it negative. Oops, I said 26. Make it negative, and then I wrote positive 26. So I got negative 26 j's. And the k's are -12 minus
3. Oh, 2.
2.
Yeah. I'm just.
Y'all suck at arithmetic, and so do I. I would recommend that when you calculate cross products, you write everything down carefully so that when you get hung up and the problem's not working and call me over to look at it, I can be like, that one. Right? If you don't write it carefully, it takes me a longer time to check and a longer time to help you. Okay, what was our k? We got minus 14 k's. Boom. There's your vector parallel.
Now, if you want to do the same thing for a perpendicular, you just turn that one you just got perpendicular, right? Or
If I wanted to do the same, what do you mean the same thing for
like
perpendicular?
if they were asking to find one that was perpendicular to the line of intersection, would you just take the one that you just found and make that perpendicular to the parallel vector?
I would have a much easier time doing that. So if it asked for a vector that's perpendicular to the line of intersection, either of these would have worked. It is not actually a trivial thing to take a rando vector and make something perpendicular to it, right? Because there's an open degree of freedom in there. Like, if I have this random vector, right, and I want something perpendicular to that, like, all of this stuff works. You're going to set the dot product equal to 0 in that case and try to solve, right? But there's going to be an extra variable in there. That kind of make sense? So yeah, and that's really that there's more than one option. Which also it should be noted that the cross product is really a special thing to R3. It doesn't work in R4 because if you take two vectors in R4 and do something with them, there's not a unique perpendicular vector. Like there's a whole mess of options. In here, we don't even really have a unique perpendicular vector, but we said some stuff to make it work. In R4, you can't even say some stuff to make it work. There just isn't anything that works like a cross product. Cool? All right. Oh, I said this was true, right? There is a way to get that. You guys want to see where that came from, or are you okay?
I'm just curious.
Yeah? Okay. So, let me stop this.